Hey everybody, this is my math video for 10.1 and I believe there's going to be a Google form coming out for the assignment, but if you're looking at the pages of your workbook, the assignment would be pages 537 and 538, but I think we have a form made. So this chapter deals with various shapes and finding area, and a quick definition of area is that when you were looking at a two-dimensional shape, square, triangle, parallelogram, rectangle, whatever, no matter what, when you're talking about area, it's the number of unit squares needed to cover that space, and those squares have no gaps between them and no overlaps. And I got the word unit underlined here because that unit could be different things. It could be yards, it could be centimeters, it could be miles, it could be kilometers. It could be feet, inches, whatever, but just realize that you are talking about the number of squares needed to cover that space. So today for 10.1, and in this chapter you're going to get a lot of formulas, and it'd be a good idea to make sure that you create a cheat sheet for yourself, and that way you can stay organized with these shapes. But the square, area of a square and area of a parallelogram has the same formula. And my letters here stand for area, and that equals base times height. And depending on your label is going to be some kind of a unit, and it always has to have an exponent of 2. And that 2 represents that you're finding how much area or how much space a two-dimensional shape covers. And so when we go through this, it's very simple to do. All you are doing is multiplying when you're finding the area, and sometimes you're going to be working backwards where they give you the area, and then you might have to find the base or the height. So if you have to work backwards, you simply use the reverse operation, and I hope you're thinking to yourself, if I multiply to find area, to work backwards, I'm going to simply divide. So these are some of the problems that you're going to see on your form or your assignment. This is a parallelogram, and this math lesson is very basic, is that remember the area is always base times height to find it. And with a parallelogram, the nice thing about most math books is what they're going to do is you'll always know that one side, top or bottom, is going to be your base, but then you also have this little dotted line in here. It could be a solid line that's your height. You never, ever, ever worry about the slant in a parallelogram. It's always the height that you worry about. So they might have a number out here, but you don't worry about that number when you're finding area. It's always this number within here. So doing the process, if I have the base and the height, 6.3 meters, 2.1 meters, I'm going to multiply those two together to find the area. So quite simply, 6.3 times 2.1. Looks like I have a 1 here, so I can go down to 63. And for those of you that follow my homeroom, you know I do X's instead of zeros for the next line. So 2 times 3 is 6. 2 times 6 is 12. And I'm going to add those two numbers together. And so when I add them, 3, 0 is 3. 6 plus 6 is 12. So 2 down, 1 up. And the last part I got is 13. So here I had 1 decimal point in, here I had 1 decimal point in, so that's going to make me drop down to have 2 decimal spots that need to be taken up behind the decimal. So my answer here is going to be 13.23 or 13 23/100 meters squared for my label. So it's simply going to look like that for area. Base times height, pretty straightforward. So same thing with the square. I'm not a very good artist, remember, so remember the definition of a square is a shape that has 4 sides to it. All angles are the same, 90-degree angles, and then all sides are the same length. So again, the area to find this is base times height. So if one side on a square is 9.5 centimeters, so are the other 4 sides, but all I need is 2 dimensions. So going to multiply these out, base times height, 9.5 times 9.5. 5 times 5 is 25, 2 or 5 down, 2 up. 9 times 5 is 45, plus that 2 is 47. Drop my x, 9 times 5 again is 45. And then 9 times 9 is 81, plus that 4 would make it 85. And now I add my two lines together. 5 plus 0 is 5. 7 plus 5 is 12. So 2 down, 1 up. 1 plus 4 is 5, plus 5 is 10. And I carry that 1 over to get that 9 in the last column. One number here behind the decimal, one number there behind the decimal. So now I have two numbers behind the decimal. So the area of this square is 90.25 or 90 and 25 hundredths centimeters squared. Okay, so that's pretty straightforward. Parallelogram, square, base times height, find the area. Next thing is what you'll see on your forms is you have the area given to you and then another dimension. So in this case, they give you the dimension of the base to be found, so now we have to find the height. So remember when I said at the start of this video, we take base times height to find area. Well, now we have to work backwards to find either the height or the base, and when you work backwards, you divide. So to find it, you always take the area divided by the base to get the height, or area divided by the height to get the base. So in this case, we want to know what the height is, so this is the formula that we're going to use. So I'm going to put 98 is my dividend, which goes under the shelf. 14 is my divisor. 14 goes outside of the shelf, and then I got to ask myself, how many times can 14 go into 9? I know that doesn't work. So I have to ask myself, how many times does 14 go into 98? And I know that 14 can go into 98 7 times. So 14 times 7. First one is 28. 8 down, 2 up. 1 times 7 is 7, plus 2 is my 98. So I know that this is right. Now the kicker here is remember that you are not finding area, you're finding height. So therefore, when you find the height, you don't worry about that exponent. You just simply put in 7 feet, no exponent. So again, finding the height or the base, take the area and divide by what you're given. So in this case, the base was given to me. I take area divided by the base, 98 divided by 14, and I get 7 feet at the height. And again, you can always check them. So I did that checking over here. 14 times 7 is 98. That's my area. It all works out. So this is my height for finding that parallelogram. Next one, since it's been a while since we've done fractions and division, all that is the same type of a problem. So again, area is given to you and the base is given to you, so you need to find the height. So area divided by the base is going to give us the height. Now remember, with fractions, you need to use reciprocals. So reciprocals are when you flip a fraction upside down. So it's always the second fraction that you flip. So if I were to rewrite this formula out with this particular parallelogram, I would have 1/2 divided by 3/8, and that's going to give me my height. So I'm going to do my work down here. So 1/2, and the reciprocal is the only one we worry about here, the divisor. The reciprocal of 3/8 is 8/3. And that division sign changes into a multiplication sign. So this is again a deal where we can cross reduce. For those of you that don't like to cross reduce, 1 times 8 is 8 as the numerator. 2 times 3 is 6. So now I have that improper fraction. But for those of you that like to cross reduce, I'm going to take a moment and pause and ask yourself, can any of these numbers that are diagonal buddies be reduced down? And you should be thinking to yourself, well, I can reduce 2 and 8 down because a number can go into both of them. That's the same, and that's the number 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. And now I have 4/3. So to put it in lowest terms, we have an improper fraction, and we're going to make it a mixed number. So either way, 6 can go into 8 one time. 3 can go into 4 one time, and then my numerators stay the same. So I know that when I take 1 times 6, that's 6. How many are left over? 2. 2. And when I take 1 times 3 to get 3, how many is left over? 1. Now the only thing is that I got to reduce this down into simplest form, and both 2 and 6 are divisible by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3, and therefore we have the same answer. Now the kicker here again is the label. Remember, we're not finding area, we're just finding the height. And so my label is just simply miles as the height of that parallelogram. So that's how you do those if fractions are involved. So the last couple problems are all dealing with the lesson or the objective for today. I wanted to throw this one at you because on the back, which I know you'll probably be getting a form, it's going to read a little bit different. But they're going to ask you pretty much, what kinds of points lie on this equation as far as a linear equation. Remember, a linear equation is a straight line on a coordinate plane. And usually we introduce this in 6th grade, and so if we were to have class, and this particular day, would come and go, I would always tell kids that anytime you're given a question where you need to find a point on the graph or a point on the line, always make your t-table with x and y. And I showed you horizontal t-tables. I'm going to show you a vertical one today. So the biggest problem that I've seen teaching math is, kids, when they get introduced to this, they always say, well, what do I need to use for x? I don't know how to get started. And I always tell them, well, anytime you're given a problem like that, just simply take 2 or 3 numbers and just use them for x. And the smallest numbers that are the best to use are simply going 1, 2, and 3. The reason why I say 1, 2, and 3 is because usually with every equation that is given to you, it's easy to do 1, 2, and 3 in your head. So remember that you have a mash here, a number next to a letter, and that always means the process of multiplication. So we simply take our values for x and we put them into the equation. So if x equals 1 and we're multiplying, 3 times 1 is what for y? And you should be saying the number 3. If x equals 2, 3 times 2 for multiplication, you're hopefully thinking 6. And then the last one, if x equals 3, multiplication again, 3 times 3, hopefully you're saying to yourself 9. Now, the nice thing about this is that what you have done is you've just created coordinates on a coordinate plane. The only thing that's missing here is the parentheses around these coordinates. So this could be a possibility of an answer for number 6 if this was your equation. I could say, well, 1 point on that line would be 1 and 3. Or you could use this one. This is another point that would fall on that line, 2 and 6. Or it could use this one as a third point. Any of those, if I were to draw out a coordinate plane and graph it and put that straight line on there, these 3 points would form a straight line on the coordinate plane, and that's what it's asking you to do. So anytime you see a question like that, make a t-table. The numbers you should use every time are 1, 2, and 3 for x, and then put those into your equation, and then you do the multiplication in this case, and you get those points. So that should help you on one of the questions. Again, email me if something's not sticking, but hopefully that made sense to you. And yeah, just let me know if you need help. Take care of yourselves.